So let's do a recap of today's what we've learned, and then I'm going to set you loose with some practice tied to Russian egg roulette, and then the quiz will be tied to one of my favorite novels of all time. Probability. What's the chance something happens? What's the rate something happens? What's the likelihood something happens? Really, there are two kinds. There's the theoretical, which only really exists in, card games, casino games, coins. Yeah, like coins, dice, spinners. You play the game of life, spin the little spinner. There's 10 spots that are, out of 10. And they're convenient because you can see all the possible outcomes and you can establish the rates for theoretical probabilities as, number of successful outcomes over total number of outcomes. I mean, that's awesome because it's exact, right? Like, that's exactly what the theoretical probability is. But it's limited. It's limited. These are great. They're perfect, but they're limited to the ones you can actually get. And I'm going to have you reanalyze Russian egg roulette through that lens. Because it's nice. It's nice to be able to do number of successful outcomes over total number of outcomes. Okay, that's nice. Limited, though. What's more realistic? Empirical ones, experimental ones you actually can draw an experiment to get. So, same kind of fraction, absolutely. But instead of the number of successful outcomes that you can count, it's the number of observed successes. The number of observed successes, 2 S's, right? Yeah. Divided by the total number of trials you ran an experiment. That's what we were doing here. We were watching an experiment go by and then just keeping track of all the results and then forming a fraction which became a percentage based on that. This is how all research statistics is done. This is how very, very early on you learn probabilities, but it's limited to those things that you can count in totality, which most things you can't. That's why this is a bit more applicable and what we're going to spend most of our time doing later in this course. A couple of the things to discuss before we let you go. I mentioned this in, I forget which video it was today, that sometimes successive probabilities depend on something that has happened before. We're going to come back to that in a project, your second project. It's called conditional probability. It's a small subset of this course. It's an important subset of this course because you can use it to measure very important things. We'll come back to that. The other thing I want to chat about that we'll also come back to, remember how the theoretical probability of getting a raw egg on the first draw was 1 out of 3, 33%. But the empirical probability that we got was at 34%, a little bit higher. That's because although theoretical probabilities are perfect, empirical probabilities are not. These are often extraordinarily close to these in value. Now, how do you make approximately equal less approximate and more equal? You do this with something called a margin of error. Now, again, if you've had Math 105, you've seen this a little bit, and we're going to get back to that about halfway through this course. So I don't want you to worry about that right now. Just realize that if we do good sampling, and this is also tying to your first project, empirical probabilities will approach their unknown theoretical counterparts. From a statistical lens, the theoretical probability is a parameter that you're never going to know. The empirical probability is a statistic that you're allowed to collect or able to collect. Not allowed to collect, you're able to collect. Okay, I think that's enough for today's videos. Let's have you get a shot at the homework and the quiz if you like.